Good morning, everybody, grade 8 and 9 learners and colleagues. A continuation of our subject mathematics and relationships. My name is Tapelo Pito, subject advisor for Moteo District, responsible for mathematics in grade 8 and 9. So we'll still be talking about properties in straight lines and see how the equations make an easier life for us in solving some problems. Right, like I said, we're still continuing, but today we'll be focusing more on the last two bullets, your equations in triangles, as well as your quadrilaterals. Okay, all right. Let's continue now. Once more, last time we were talking about properties, and I said, and I'm still encouraging you, you are able to do mathematics yourself. Yes, somehow you might need some assistance from your classmates, from your teacher, and so on. But like I said, looking at the properties, doing them, you understand them, you are getting the picture. Let's say, for example, you take your triangle there. A triangle, if it's a three-sided figure with three angles, if you cut all those angles like they indicated here, you just join them, they will give you a straight line. And remembering that all angles of a triangle will give you 180. Obviously, when you cut them, give you 180, but let's have a look and see what happens. It gives you 180, which is a straight line. Therefore, it's reminding us angle on a straight line add up to 180. Always remember that. When you see a straight line, remember the angles on the straight line there gives you 180. Same thing when you with your quadrilateral, your four-sided figure, 1, 2, 3, 4. You remember as well, last time I spoke about your rectangle as well. Your rectangle there, which is four-sided. Remember? Your rectangle, let's see whether this whole page will fit here. Your rectangle, which is four-sided figure. There it is. There it is. Okay, let's make it a little bit smaller so that it can fit, but you know what is a rectangle. When you look at the table, when you look at your desk, four-sided figure. When you look at your books, when you look at your pages, four-sided figures. 1, 2, 3, 4. That's why we say quad, which means four. Quadrilateral. Your quadrilateral. Lateral, which is your sides, which means your sides. Your sides. So it's a four-sided figure. 1, 2, 3, 4. Your quadrilaterals. And of course, remember your angles here. Remember, it's a rectangle. This particular one is called a rectangle. Rectangle because of 90 degrees, remember, because of a right angle. So we call it a rectangle. Rectangle. Because of those right angles. Those right angles. And of course, we know right angles equals to 90 degrees. So there are four 90s. 90 plus 90, 180. 180 plus 90, 270. 270 plus 90, 360. Therefore, it's a given. You see four-sided figure. When you add all the angles, they will give you 360. Even if you cut them around and put them around a point, they will give you 360. That's a way of reminding yourself. Like there, where you are given a four-sided figure, you cut all those angles and you put them around a point. Angles around a point equals to 360. Angles on a straight line equals to 180. Remembering your theorems of your straight lines. Theorems of straight lines. Now let us continue. Another way of doing it as well as you have your triangle there, the grayish one, and outside there is a triangle, an angle. outside, because remember we're talking relationships, there are angles inside this triangle. Any angle outside is called exterior. Angle A and B and C are angles inside. Now we'll say the angle A and B. You see, this angle here represented here, exterior angle, will be equal to 2 interior opposite. Opposite, 2 interior, they are interior, they are inside the triangle, but opposite. Remember those. This is opposite, facing each other. Angle C is next to this one, so it's adjacent. So we are not talking about adjacent, we're talking about opposite. Exterior angle equals to 2 interior opposite. Same thing here, when you take your B and C here, your exterior angle will also be equal to 2 interior opposite. These are the kind of things that you can see and do. Always have them in front of you. Always ensure how are you going to remember, because what is important is how are you going to remember, and we remember differently. We write tests on our own. We understand differently. We get pictures differently. That's why in English sometimes they say it in your own words. But doing these things, observing, looking at them, trying and looking at the properties, and the language is important as well. Adjacent, opposite, that is the language that you need to build, the vocabulary that you need to build. It's a new language, therefore it needs more time to work on. So how are you going to remember? That's what's important as an individual learner. Last time we spoke about this, let us remind ourselves again. We have just agreed now, we have just learned that angles on a straight line will give you 180. When you add angles on a straight line, and can you see above the line is 180, and obviously below the line is another 180. Therefore, angles around the point will give you 360. Therefore, again, you check equation. 50 degrees plus 8 degrees must be equal to 180 degrees. Why? But remember statement and reason. That is very, very crucial. Statement and your reason. Statement and your reason. We'll deal with it when we continue with other questions. But here, when you look at it, angles, it's a given. In other words, it's in front of you. Yeah. What you just have to do is just to tell us what is in front of you mathematically. You've got a straight line, 50 degrees plus 8 degrees. Are they on a straight line? Yes. And if they are on a straight line, what do they add up to? To 180. So you give a statement, 50 degrees plus 80 degrees will give you equals to 180. What is the reason? Angles on a straight line. Same thing, 35 degrees plus B degrees, are they on a straight line? Yes. Would they add up to 180? Yes. Why? Because they are on a straight line. So it's something, it's in front of you. There's nothing difficult. It's something that is in front of you. Just tell us what you see, but of course mathematically. At the end of the day, you have to talk that language that you all understand, the mathematical language. Same thing here. Adjacent angles, angles next to each other. Adjacent angles, angles next to each other. Adjacent angles, angles next to each other. But we say adjacent mathematically. And are they on a straight line? Yes. Therefore, if on a straight line, what is the total? 180. It's also given here. Angle on a straight line. Here we've got 90 on 90. They are on a straight line. Therefore, if this is 50, for example, A, for you to get 180, you need 130. For you to get 180, you need 145. Remember again here, still on a straight line. You must check, what do you have? Do you have a straight line? You must always look, what do you have? What is in front of you? What are you giving? Tell us what you are giving, but mathematically, because you convince us, giving us an evidence. Again, it's a straight line. Is it a straight line? Yes, let's see. 120 plus 60, 180. Oh, it means it's a straight line. Let's check this one. Is this one also a straight line? 120 plus 60, 180. Oh, therefore it's a straight line. Let's check this one underneath. 160 plus 180 is a straight line? Yes. 180? Yes. And if you add off all of them around the point, is it 360? Yes. So in other words, it's in front. You talk about what is in front of you. And let's look at the relationship of the green angles. They are opposite each other vertically. They are called vertically opposite. What about them? They are equal. Yes. Vertically opposite angles, what about them? Are they equal? Yes. And then remember last time, that's what we did, how we solve our equation. A plus 60 equals to 180. And when you transpose 180 minus 60, you get 120. Same when you look at the questions. What are you given? Which one is easy? Let's look at for angle F. Now you must look at the relationship. Oh, angle F is on a straight line. Therefore, you can say something about straight line. Angle F plus 40 degrees equals to 180. Angle D on a straight line. Therefore, angle D plus 40 equals to 180. Angle D and E on a straight line, but you don't have much information. But what do we have? Vertically opposite angle. Angle E equals to angle 40. Vertically opposite angles. Remember, it's just reminding us how to go about the approach. Look what you have. Look at the easiest way out. Or whatever, the way you see it, the way we understand it differently. Others will start with angle E, or even myself, I start with angle E equals to 40 degrees, vertically opposite. Whereas somebody will start with the straight line here with D and E. We are different, but what is important, always look what is in front. What do you have? What kind of angles do you have? What relationship do you have? That's what is important. Again, as a reminder, vertically opposite angle, equal. Vertically opposite angle, equal. Vertically opposite angles, equal. Vertically opposite angles, equal. And because these lines are parallel as well, we spoke about parallel lines. Corresponding angles. What do we mean by corresponding angles? These two angles, they are both above the parallel lines and on the right of a transverse. So they've got something in common. Above the parallel lines and both on the right side of a transversal line. We call them corresponding angles. And in other words, you just explain what you see. Right? Let's look at 50 degrees and 50 degrees. What can you say? These 50 degrees, they are between the parallel lines, but on either side of a transverse. In other words, they're alternating, and they are equal. Therefore, alternating angles of parallel lines. They're alternating between the same parallel lines, but on either side of a transverse. That's what you see. That's what you need to learn. And again here, what can you say about 50 and 130? There is something here about 50 and 130. When you add them, what do you get? 180. What can you say? Now the relationship, talk about the relationship. Where are they based? These two angles are within the parallel lines and on the same side of a transverse. They will give you 180 degrees. And they are called co-interior. They are internally together. Co-interior, internally together. Same thing. What do you see here? 130 and 50. What do you add? What do you get? Our measuring now degree, 180 degrees. But how do you explain these two angles? They are within the parallel lines, between parallel lines, inside the parallel lines, interior, on the same side of a transverse. Those are called co-interior. Again, the point is, how would you remember? That's what's important. Now, let's have a look now. Let's have a look now. I will guide you. I give you an approach while you are busy working at it. You are busy working at it. What do you remember? In other words, what do you see? What is in front of you? What are you given? And then when I'm discussing, I'm giving you an approach, I give you that opportunity of opportunity of working it out yourself. Right, what I see here, I see a straight line. Number one. And what do you know about straight line? When you add them, when you put them together, they will give you 118. That is a hint of Roman 1. And then Roman 2, what do we have? We have a straight line. Not necessarily. We cannot be sure here. But what are we certain about? We are certain about that we have got all angles around a point. All angles around a point. What about angles around a point? They will give you 360 degrees. All right? I'll give you 3 minutes to work on those. I've given you an approach, how to approach them. Just work on them, and then we'll be back again now quickly.